some of the models. Okay, that is the some competition models in the embedded systems. Okay, we are discussed about some of the data flow models, control data flow, graph models, stack machine model, the state machine model. Okay, in that we are also discuss some of the final state machine model also, and sequential program models, and then communicating process model. We have one more important model is the objective-oriented model. Okay, these things we are discussing in the previous class. Today we are going to discuss the new topic, just the embedded firmware and design and development. Okay, in the last class also I given the introduction about the embedded firmware business. Okay, it is responsible for controlling the various peripheral. Okay, it is responsible for the controlling the various devices of the embedded hardware and generating a response to the cadence of the functional requirement. Here, the framework is considered as a master plan of the system. Okay, it's impacting the intelligence of an embedded system is a one-time process and it can happen at any stages. The most of the embedded product, okay, all the software programs or control programs are stored in the permanent magnet that are read on the memory, and this program cannot be altered by the users. Okay, and then similarly, some of the embedded products can be used as a control and instrumentation domains are adaptive. Adaptive is nothing but some of the advanced technology, adaptive technology like ANN, machine learning programs are used for this control and instrumentation domain. And coming to the designing of a embedded framework, first we should understand in the particular embedded product hardware, okay, like the components, details, and how many components are interfaced with that particular systems and memory mapping details, and input output details and configurations, and register details of various chips used in the programming. Okay, this should be known before designing the embedded frameworks. And embedded framework development process start with the conversion of the software requirement into a programming model using the modeling tools. Okay. First, what we do is what is the requirement? What is the software requirement is there for developing the embedded framework? Okay. First, we have to identify the conversion of the software requirement that should be converted into a model by using the modeling software, like example, MATLAB, Simulink, anything, etc. Or C, C++, Python. Okay, once the model is created, okay, once the model is created, then we go for the next implementation stage. Okay, in that we are to creating the task and action by capturing the model by using the language. It's target process, which is defined by the target processor or a controllers. And also, you have two types of firmware design approaches. The first one is the super loop based approach. There is a conventional processor based design, and second is the embedded operating system based approaches. Actually, if you go for designing a process for the same software, okay, it is more dependent upon the function, the speed of the operations. Okay, based on that, we have go for these two technology strategies to create to design this system. One is the super based approach, and second is the embedded operating system based approaches. Yeah, coming to the super loop based framework development approaches adopted for the application that are not time critical. Okay, that is not a time critical means it means that it not taking time. Okay, and where the response time is not so important. Okay, the response of particular that time is not important. We are using this super loop based framework approaches. So it is also called as a conventional procedural based design. So here if you want to adopt this kind of approaches means this approach application, okay, where we are using this application that are not a time critical, and also the response time is not as so important. Because of this, it is very simple, similar to the conventional procedural programming where the code is executed task by task. Okay, the task listed at the top of the program code is executed first, and the task just below the top or execute after completing the first task. Okay, task by task. Okay, in the previous class we have discussed some tasking, some task related statements. The task is first what work they should after completing the first one, then go for the second task. Like that. Here also this approaches the programmable code is executed first, and the task just below the top or executed after completing the first task. Okay, if you go for next task means the first task will be completed and then we'll go for the second task. Like okay, the multiple task based system, each task is executed in serially in this serially. Okay, after completing one task, then we'll go for the next task. That's why it is a that's why it is very similar to the conventional programming. Okay, where the code is executed by the program executed task by task. We can see there is a execution flow. Okay, software execution flow for this will be you can see the first one is the configuration. Configure the common parameters and perform the initialization of various hardware and component memory systems. Eventually, we should connecting the what are the hardware components should be means initializing the all the hardware components like memories in the microcontroller. Okay, in the previous semester, in the previous year, I studied the microcontroller. There's some of the hardware parts will be there. Okay, before executing the programs in the logic domains, we should introduce the hardware components. Okay, and also some of the common parameters for the particular hardware. Okay, then after the second one is start the first task and execute it. Okay. Then the second will be the second step for this super load based operation is the start the first task and execute it. Again, after the completing the execution of the first task, then we go for the second task. Okay, serially. It is a serially execute the second task, like the execute the next task, like continuous. Okay, last execute the last relevant task. Okay, after that, jump back to the first task and follow the same flow. Okay, like that, it will be continuously execute the programs. Okay, this is a way the program will be executed in serial task. Executed task by task. Okay, first usually you should configure all the parameters and insert all the particular systems. Then you go for the then after the installation of the component, then you go for the compiler running the program. First task will be executed, then you go for the second task. After the third at the end of the execute the last different task, then you go jump back to the first task and follow the same flow. Okay, then we can see how to write this program also. See the order in which the task can be executed are fixed and they are hard coded in the code itself. Also, the operation is a infinite loop based code. Okay, usually the C program code are used to create this programs. You can see have it menu initialize after configuration. There's a main syntax for our first program bracket for bracket and then configuration the parameters initially the order and it is executed as transfer class. Okay, this is a way to add the so this is one kind of format. Okay, this is one kind of format for super loop based approach. See, in this case, all the task, almost all the task is embedded application are non-ending and are repeated infinitely throughout the operation. Getting see in the last task, after the last task, different after different the last task, the jump again move to the first task. Okay, and in the same follow the same program. Okay, yes, almost all the tasks are embedded application are non-ending and are repeated infinitely throughout the operation. This repetition is achieved by using a infinite loop. Okay, that is called as a super loop based approach. Okay, in this repetition, the program will be executed repeatedly okay, by using the infinite loop. Okay, this means this infinite loop can be also called as a super loop based approach. The only way to come out of this loop either a result or an interruption through an interruption or a hardware reset. If you want to come up this super loop based approaches, means if you want to do is then reset the hardware components. Okay, otherwise interrupt should be entered the particular program. The hardware reset brings the program execution back to the main loop. Okay, and then interrupt request. Okay, interrupt request suspend the task execution temporarily and perform the corresponding interrupt routines, and then completion of the interrupts routine is reset. Restart the task execution from the point where it goes to interrupt. Okay, ಅದೇನಪ್ಪ ನಾವು ಅದೇನು ಲೂಪ್ ನಾವು ಸ್ಟಾಪ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಹಾರ್ಡ್ವೇರ್ ರಿಸೆಟ್ ಮಾಡ್ತೀವಿ. ಹಾರ್ಡ್ವೇರ್ ರಿಸೆಟ್ ಮಾಡಿದ again we go back to the main otherwise the second method is the interrupt method. Okay, suppose the interrupt actually the main problem temporarily stop ಮಾಡ್ತೀವಿ. Okay, suspend the task execution temporarily and then perform the corresponding interruption routines, and on completion of these interruption routines again restart the task execution from that part when it got interrupted ಅಂದ್ರೆ ಎಲ್ಲಿ interrupt ಆಗಿತ್ತಲ್ಲ ಅಲ್ಲಿಂದ ಮತ್ತೆ execution start ಆಗುತ್ತೆ. Then what is the advantage of this super loop based approaches? Okay, see in this loop does not require any operating system. Operating system not required for this one. There is no need for scheduling because it is not time dependent. It is not the system is not in the real time. Okay, that's why immediately there is no need for scheduling which task needs to be executed and assigning the priority to each task. No need to scheduling the task. Scheduling which task is to be executed because all the tasks can be executed serially. One by one. Okay, there's no need to schedule the task which task is to be executed and task. Then priority are fixed and other and the order in which the task is executed also fixed. Priority fixed, everything is fixed because after completing one task, then you go for the next task. Like that. Okay, here there is no need to schedule the task, no need to fix the task, no need to order the task. Okay, first or second line. Is the code for performance task inside the code memory without an operating system images. Okay, these are the advantages. Okay, and the application of the super loop based approaches. This type of design is developed in the low cost embedded product and product where response time is not time critical. Okay, that's one of the application here. Low cost and then this product where response time is not time critical. Okay. The second one is the some of the embedded product depends the type of approach. So some task itself are sequential. Okay, ಎಲ್ಲಿ ನಾವು ಸೀಕ್ವೆನ್ಸ್ ಅಲ್ಲಿ ಟಾಸ್ಕ್ ರನ್ ಆಗ್ಬೇಕಾಗುತ್ತಲ್ಲ ಅಲ್ಲಿ ನಾವು ಈ ತರ ಸೂಪರ್ ಬೇಸ್ಡ್ ಕಂಟ್ರೋಲ್ ಡಿಸೈನ್ ಎಂಬೆಡೆಡ್ ಸಿಸ್ಟಮ್ ಟೇಕ್ an example for reading and writing the data to and from a card using a card reader require the sequential of operation like checking the presence of the card, authentication of the operator, reading, writing, etc. We are using this kind of super loop based approach. It should be restricted follow a specified sequence and the completion of this series of tasks constitute a single task, namely data read and write. Where in this reader and write data from a forms from a call using the card data where they are using this kind of because the process will be going on sequential. They will check the presence of the card, the authentication of the process means it should be there. So you give the card, the card will submit and the next will go for the authentication like that. Again, reading the data will be data will be right, etc. Okay, then we are using this sort of approach. Each resource access and make a single resource to it. And a single resource to it. One more example is given here. The typical example of super based product is an electronic game. Okay, video game is also one of the example for this super because see in the video game they have chapter 1, chapter 2, chapter 3, other task 1, task 2, task 3. One task complete agade then go for the next task. Okay, video game toy containing the keypad and display unit. The programming running inside the product may be designed in such a way that first is the key to detect whether the user has given any input and if any key is pressed it is detected the graphic display is updated. Okay, then the keyboard is scanning the display, scanning and the display is updating the icon at the reasonable height. Okay, even if the application misses a key press, it won't create any critical issues. Rather, it will be treated as a bug in the file. It is not a, and then it is not a economical system and operating system. It's a low cost product. It is very rest to know so is a response government are not critical. Okay, very simple. Okay, this kind of scroll based, task based approaches that can a simple toys means a simple system because it is not this type of response is not a crucial. Okay, ನಿಮಗೆ ಯಾವಾಗ ನೀವು ಸಿಸ್ಟಮ್ ನ and then drawback of the super low based control approaches. See, in any one sequence part, any single task effectiveness, total system will be another effect ಆಗುತ್ತೆ. Because of all the tasks will be executed serially, serially execute ಆಗ್ತದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ any one task must fail. Okay, then entire system will be affected. Okay, that's why any failure is not a part of a single task will affect the total system. Okay, if the program is suppose on a point while executing a task, it will be remain there forever and ultimately the product stop functioning. Here the watchdog label can be used to overcome this, but this in turn it causes additional cost and failure over it. Okay, a watchdog label use ಮಾಡಬಹುದು ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ error ಆಯ್ತು ಅಂದ್ರೆ but it takes some because if you are adding this watchdog label additional cost also increases and then some software are for that particular hardware. And then the second was the lack of real time. The second drawback is the lack of real time. Okay, because the support loop composite approach or real time operate ಆಗಲ್ಲ. Okay, it's not time crucial. Okay. If the number of tasks can be executed within application increases, the time it tasks repeated also increases. So this brings the property of some emails. Some of the example is in the system the key press. Okay, in order to identify the key press, in order to identify the key press, you may have to press the key for a sufficiently long time till the key press status monitor is executed internally by these softwares. Okay, that's one example. That's one of the drawbacks for this super loop based control approach. The one is the when it has failures, the whole system will be goes to affected. Suppose the second topic is the lack of real time test. Because this kind of programs will be operated in a non critical not time it's not time crucial. Okay, it is not working in a real time. Okay, then uh, next approach is the second approach. There is embedded operating system based approaches. Okay, it means that there is an operating system are used to perform these operations. Okay. The embedded operating system based approach. The embedded operating system based approach contains the operating system. It contains it can be either a general purpose operating system or a operating system to host the user in that application software. ಅಷ್ಟೊತ್ತಿಗೆ ನಾವೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ operating system ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. Operating system general purpose or it could be a real-time operation system. Okay, by using this operating application software. See, suppose there is a two process will be there. Operating system may be a real-time approach, or it may be a real-time operating system, or it may be a general purpose operating system. The general purpose operating system based on reason is very similar to the conventional PC. Conventional PC ಅಂದ್ರೆ ನಾವು ಏನು ಡೆಸ್ಕ್ಟಾಪ್ ಯೂಸ್ ಮಾಡ್ತಿದೀವಲ್ಲ ಏನು ಲ್ಯಾಪ್ಟಾಪ್ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ very similar to that one based on the application development where the devices contains the operating system it may be Windows, Linux, etc. Okay, and you will be creating and running the user application on the top of it. Okay, creating and running the user application ಏನು user application develop ಮಾಡ್ತಿರಲ್ಲ ಅದನ್ನ ಅಲ್ಲೇ know ಮಾಡ್ಬೋದು. Okay, example can use okay suppose you can use this general purpose operating system based design means you can use this in the embedded product development in the Microsoft experience. Okay, Microsoft experience development system software development application means software very good. Okay, example of this embedded product using a Microsoft Word XP or operating system personal digital assistants, handheld devices, portable devices, and point use case these are the embedded product. Okay, this embedded product system is also the purpose of it. System you can easily software and use of this GPUs. The purpose of systems in embedded product. That's Mazda. Merge this general computing system in terms of operating system for developing the application on the top of the OS. Okay, see the operating system is the base platform. Okay, use that base platform only we can go for developing the application software. Okay, that application software is supported by this once. Okay, ಅಂದ್ರೆ very simple ಒಂದು C program. Okay, ಒಂದು control program ಬರೀಬೇಕಾದ್ರೆ ನೀವು operating system ನ ನಮ್ಮ ಲ್ಯಾಪ್ಟಾಪ್ ಇರುವಂತಹ ಸಪೋರ್ಟ್ ಮಾಡುತ್ತೆ application software. Okay, similar to the different drivers using different types. So in the system application also drivers and the different driver project want to communicate with them. Okay, if you want to connect some external or hardware devices means for the particular hardware. If you take an example, if you want to connect the printer to your laptop means if you connect this, it not take first what to do driver software the particular. Okay, suppose you take an example for each laser means laser have some driver software that should be installed in your operating system. Then only that particular support with the your operating system. That's one example. Otherwise, if you go for any communication devices, okay, any Wi-Fi, you connect it to your laptop. There is some driver software. Firmware software with it. By using the driver software, we can communicate the, we can connect the hardware. There. Second, I repeat the similarly the driver software specific drivers. Opening the system based application also require the driver software for the to communicate with them. Okay, for communicating with them, you need some driver. Driver means driving the means the running the particular hardware or software. You need software. Okay, so suppose if you are writing programming means okay, one C program. Control program you should write the same program. The same program software we can get. Okay, that should be installed in our operating system. That is our driving running the particular software. Okay, operating software, running software for all the hardware as well as software drivers. Okay, clear about this? Any doubt regarding this? Any doubt? Say yes or no.
No, sir.
Okay. No, sir. That's a GPOS. Okay. ನೀವು ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ suppose your system in the your mobile phones in the earlier days what happened all the operating system now it is Android based mobile phones and previously nowadays it was a Java based. In the Java based Android based application Java based Android Java based the programming application Android mobile install ಮಾಡಿದ್ರೆ it is not supporting. Okay. But what is that? Our operating system support all the application with a sort of driver software. Okay, sort of driver software. ಎಲ್ಲ ತರದ ಸಾಫ್ಟ್ವೇರ್ ನಾವು ಇನ್ಸ್ಟಾಲ್ ಮಾಡಬಹುದು ಅದೇ ತರ ಹಾರ್ಡ್ವೇರ್ communication connect and mobile phone connect some driver software should be there. That support there will be the devices will run the operating system. Again, the next one is the real time. Next one is the real time operating system. Okay, the real time operating system is based on the approach is applied in the product demanding the real time response. ನಾವು the real time operating system ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಎಲ್ಲಿ ನಮಗೆ real time response ಬೇಕು where we are required real time. Okay, ಅಲ್ಲಿ ನಾವು ಇಂದ real time operating system ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, that is based design approach is employed in the embedded product demanding real time response. ಅಂದ್ರೆ ನಮ್ಗೆ ಎಲ್ಲಿ real time data ಬೇಕು based on the real time output drive okay output ನ ನಾವು ವೆರಿ ಮಾಡಬಹುದು based on real time input data ನಾವು ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಎಲ್ಲಿ ಡಿಮ್ಯಾಂಡ್ ಇದೆಯಲ್ಲ ಅಲ್ಲಿ we can use this real time operating system based approaches. Okay, actually this RTO is real-time operating system respond. It is a timely and predictable manner to events. A proper time and predictably manner to each events. And real-time operating system contains the real-time kernel responsible for performing the every multitasking, scheduling for schedule tasking, multiple threads, etc. ಅಂದ್ರೆ ಈ ತರ ನಮ್ದು ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಇದೆ. ನಮ್ಗೆ ಯಾವ ಟಾಸ್ಕ್ ಆದ್ಮೇಲೆ ಯಾವ ಟಾಸ್ಕ್ ಆಗ್ಬೇಕು ಅಂತ ಕ್ಲೀನ್ ಆಗಿ ಶೆಡ್ಯೂಲ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ನಾವು ಸೀರೀಸ್ ಇದು ಪ್ರೀವಿಯಸ್ ಏನಿತ್ತು ಸೀರೀಸ್ ಟಾಸ್ಕ್ ಕ್ಲೀನ್ ಆಗಿ ಶೆಡ್ಯೂಲ್ ಮಾಡ್ಬೋದು. ಇದೇ ಹೋಗ್ಬೇಕು ಅಂತ ನಾವು ನಂಬರಿಂಗ್ ಮಾಡ್ಬೋದು. ಮತ್ತೆ ಮಲ್ಟಿ ಟಾಸ್ಕಿಂಗ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಅದೇ ಇಷ್ಟು ಟೈಮಲ್ಲಿ ಟಾಸ್ಕ್ ಎಕ್ಸಿಕ್ಯೂಷನ್. Okay, ಆಸಕ್ತಿ ಇದೆ. ಅದರ ಪಾಸಿಬಿಲಿಟೀಸ್ are given this kind of operating system, real-time operating system. Okay, real-time operating system allows a flexible scheduling. The scheduling reflects of the system resources like CPU, memory, and for some of the complete particular task. And then some of the example is given based on the product development, the embedded Linux, micro slash OS, two ThreadX, VxWorks, Windows, PS was Symbiote. Okay, these are the one of the real-time. These are the operating system. There's a real-time operating system for operating the embedded product development. Okay, then mobile phones. Okay, the PDA based on Windows and C or Windows mobile platforms, Android device, etc. Example for the embedded product development was mobile phones are using the Android or Windows based mobile phones. So these are mobile platforms. Now that is also recommended that this device. These are real-time operating system. And most of the mobile phones are built around the popular RTOs. There's a Symbiote. Okay. Clear? Any doubt regarding this or general purpose and operating system? Yes.
No,
Any
sir.
doubt? Okay. Then language. Okay. Development of the embedded framework development language. ಅಂದ್ರೆ ನಾವು embedded software ಅಲ್ಲಿ ಯಾವ ತರ ಲ್ಯಾಂಗ್ವೇಜ್ ನ ಡೆವಲಪ್ ಮಾಡ್ತೀವಿ ಅಂತ, ಯಾವ ಲ್ಯಾಂಗ್ವೇಜ್ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಫಾರ್ ದ embedded framework development, we can use either a target processor or controller specific languages. ಅಂದ್ರೆ ನೀವು ಏನಾದ್ರು ಒಂದು ಡೆವಲಪ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಯು ಶುಡ್ ನೋ ಅಬೌಟ್ ವಿಚ್ ಪ್ರೊಸೆಸರ್. ಓಕೆ, ಬೇಸ್ಡ್ ಆನ್ ಯುವರ್ ಅಪ್ಲಿಕೇಶನ್ ಯಾವ ಪ್ರೊಸೆಸರ್ ಯಾವ ಕಂಟ್ರೋಲರ್ಸ್, ಆ ಪ್ರೊಸೆಸರ್ ಕಂಟ್ರೋಲ್ಸ್ಗೆ ಯಾವ ಲ್ಯಾಂಗ್ವೇಜ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಟ್ ಮೇ ಬಿ ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಇಟ್ ಮೇ ಬಿ ಲೋ ಲೆವೆಲ್ ಲ್ಯಾಂಗ್ವೇಜಸ್ ಅನ್ನೋದನ್ನ ಡಿಸೈಡ್ ಮಾಡ್ಬೇಕು. ಆರ್ ದ ಟಾರ್ಗೆಟ್ ಪ್ರೊಸೆಸರ್ ಕಂಟ್ರೋಲ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಲ್ಯಾಂಗ್ವೇಜಸ್, ಇಂಡಿಪೆಂಡೆಂಟ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಲೈಕ್ C++, Java, etc. Okay, and these are the commonly known as high-level languages, or this is a combination of both assembly language as well as a high-level languages. ಅದಾಗ್ತದೆ. ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ನಾವು ಎಂಬೆಡೆಡ್ ಫ್ರೇಮ್ವರ್ಕ್ ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಲ್ಯಾಂಗ್ವೇಜಸ್ ನೀವು ಡೆವಲಪ್ ಮಾಡ್ಬೇಕಾದಾಗ ನಿಮ್ದು ಅಪ್ಲಿಕೇಶನ್ ಬೇಸ್ ಮೇಲೆ ಯಾವ ಪ್ರೊಸೆಸರ್ ಮತ್ತೆ ಯಾವ ಕಂಟ್ರೋಲರ್ ನಿಮ್ಗೆ ಬೇಕು, ಅದು ಯಾವುದು ಆ ಪ್ರೊಸೆಸರ್ ಯಾವ ಲ್ಯಾಂಗ್ವೇಜ್ ನ ಕ್ಲೀನ್ ಆಗಿ ರೀಡ್ ಮಾಡುತ್ತೆ. ಟಾರ್ಗೆಟ್, ಓಕೆ, ವಿಚ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಇಟ್ಸ್ used for the particular processor controller identify. It may be assembly level languages or low level language, or it may be a high level language like C++. Otherwise, the combination they used. See, in the assembly languages, it is the human readable notation of machine languages. Okay, assembly languages is the human readable notation of machine languages. Machine languages is the processor understandable language. Machine language processor understand ಮಾಡುತ್ತೆ. assembly language ನೀವೇ ಆರಾಮಾಗಿ ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡಬಹುದು ಅಂತ. Okay, machine language is a binary representation. It contains only 1 and 0. Okay, high is 1 and low is the 0. Okay, machine language is made readable by using a specific symbols called mnemonics. Some of the mnemonics are used for understanding the particular language, and then as machine language can be considered as an interface between the processor and programmers. Okay, you can see in the previous laboratory microcontroller how we are interfacing through hardware with the softwares. Okay, using this machine language. The machine language can be understood, can be considered as an interface between the processor and programmer. And assembly language and machine language are process or controller dependent And an assembly language or programs written from one processor or control family will not work with the others. Even program ಬರೆದಿರ್ತಾರಲ್ಲ ಅದು ಯಾವ processor ಇರುತ್ತೆ ಆ processor ಮಾತ್ರ ವರ್ಕ್ ಆಗುತ್ತೆ. Other processor control ವರ್ಕ್ ಆಗಲ್ಲ. Assembly language program is the task of writing the processor specific machine code in using some in the mnemonic forms, converting these mnemonics into actual processor instruction. Okay, that's called the machine language, and is associated data using an assembler. Okay, clear? Once again, I repeat the sentence about the assembly language program. Assembly language program is a task of writing the processor specific machine code in the by using some of the mnemonic forms, and this converting the mnemonics into a actual processor instruction that is called as the machine language, and is associated data using an assembler. See some of the assembly language example is given here. So before going to the see assembly language program. Okay, what we are using in the microcontroller laboratory, these are the assembly language program. There's a ASM. ASM program, okay, assembly language program. Okay, there is the most common type of the program developing in the beginning of the software evolution. Okay, initially ಏನು ಮಾಡ್ತಿದ್ವು ಈ ತರ assembly language program ನಾವು use ಮಾಡ್ತಾ ಇದ್ವಿ in the embedded system. Even today, if you go for the low level systems, okay, they can use this assembly level languages. Even today, so they can use. Okay, so your senior they are doing some of the project. No, okay, some very simple project or simple thing, mini project. To do some mini project, this assembly language program are used. Okay, and in particular, assembly language is often used in the writing the low level interaction between the operating system and the hardware, for instance, in the device drivers. See, take even the simple example here, even for the assembly language based program. See, the general format of assembly language instruction is an opcode, okay, and followed by the opcodes. See, opcode tells the process what to do. Okay, the operand is the provide the information, data information required to perform the action specified by the opcode. See, example is move. Move is the opcode. Okay, there is a ಏನ್ ಮಾಡಬೇಕು processor move a comma /30. It means that move a is the opcode and /30 is the operand. Now the instruction, the same instruction will be written in the machine language like this. Okay. /30 can be written like this because it's a binary machine. Initially, I told you people the machine language is a binary representation. Okay, it consists of only zeros and ones. Okay, the whole thing, the move a /30, the move a is the printed and 30 is the opcode and 30 is the operanded, and the instruction will be written like this. Okay, 30. The first binary value represent the opcode of move a, and the second 8-digit binary value will represent the opcode of 30. Okay, this is your a, this is your 30. Clear? The first 8 bit, okay, the first 8 bit is there now. It's the value 011101000 representing the move a, and the second 8 bit binary value there is a 00011110 that is represented of the 30. Okay, this is the way. Next, see next one. See, as usually in the ARM control instructions, we are writing some of the program in the ARM control also same thing. Initially should be label after opcode and then operand and then commands. Okay, same thing also here also the same principle also followed in this assembly language program also. See, each line of the assembly language program splits into 4 fields. The first one is the label, second is the opcode, and third one is the operand. Operand will be 1, 2, 3, 4 like that. Finally, colon with your comments. Okay, a label is an operational identifier, okay, used in the extension in the program to reduce the dependency on the program for the remembering the where the data code will be located. Label. Okay, suppose example delay. Okay, loop, delay, call, interrupt. Okay, these are the labels. Okay, then what is the output in this? What is the output? A move or not is your output, and output is the /225 and colon load the register. Okay, what is the instruction for that one? Okay, see, load the register or not with 225 means that is the immediate data. 255 is the your immediate data that will be load to the register or not. Okay, that is the comment. That is the content of this explanation about this particular instructions. Okay, that should be written in the comment sections. Okay, see label will be a delay, move or not receiver output, and slash 2255 is the output. What's the explanation of that particular instruction means? The load the register or not with the 225 means 225. There's the immediate data should be load to the register or not. Okay, this is the way to write the assembly language program. Okay, clear? Any doubt regarding this? Any doubt? Yes or no? Hello?
No, sir.
Okay. See, then again, the assembly language programs written in the assembly code. Okay, that should be saved in the .asm. Okay, in the microcontroller also written some ALP program. Okay, in the ALP program, after writing the ALP program, then you to share that program in its form. That is the .asm. Okay, .asm ಅಲ್ಲಿ ನೀವು file ನ save ಮಾಡಬೇಕು. Okay, otherwise our source file .src. Okay, otherwise some file .s file. Okay, ಈ ತರ ನೀವು assembly language program ನ store ಮಾಡಬಹುದು, save ಮಾಡಬೇಕಾದಾಗ. Any text editor like Notepad or WordPad from Microsoft, the text editor provided by the integrated development tools can be used for the writing the assembly instruction. Notepad allo ಬರಿಬಹುದು, WordPad allo ಬರಿಬಹುದು. Otherwise Microsoft text editor allo ನೀವು ಇದನ್ನ program ನ ಬರಿಬಹುದು. Similarly, to C and other high-level language program, you can use the multiple sources files called modules in assembly language programs. Okay, each module will be represented by .asm or .source file. Okay, this approach is known as a modular programming. Okay, the modular programming is employed when the program is too complex or too big. Okay, ನಮಗೆ ಈ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಈ ಮಾಡ್ಯುಲರ್ ಅಪ್ರೋಚ್ ನಾವು ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಏನಾದ್ರು ತುಂಬಾ ಪ್ರೋಗ್ರಾಮ್ ತುಂಬಾ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಇತ್ತು, ತುಂಬಾ ಪ್ರೋಗ್ರಾಮ್ ಇದ್ರೆ ನಾವು ಅದ ಮಾಡ್ಯುಲರ್ ಆಗಿ ನಾವು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸಿ ದ ಮಾಡ್ಯುಲರ್ ಕೋಡ್ ದ ಎಂಟರ್ ಕೋಡ್ ಇಸ್ ಡಿವೈಡೆಡ್ ಇಂಟು ಸಬ್ ಮಾಡ್ಯೂಲ್ಸ್. ಓಕೆ, ಅಂದ್ರೆ ತುಂಬಾ ದೊಡ್ಡ ಪ್ರೋಗ್ರಾಮ್ ಇರುತ್ತೆ, ತುಂಬಾ ಸಮ್ ರೂಟೀನ್ಸ್ ಸಬ್ ರೂಟೀನ್ಸ್ ಎಲ್ಲ ಕಾಲ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅಂದಾಗ ಏನಾಗುತ್ತೆ ನಮ್ಗೆ ರೀಡಿಂಗ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೋಗ್ರಾಮ್ ಆಲ್ಸೋ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್. ಓಕೆ, ಹಾಗಾಗಿ ಏನ್ ಮಾಡ್ತೀವಿ, ವಾಟ್ ವಿಲ್ ಡೂ ಮೀನ್ಸ್ we can that main program will be the entire code that the program will be divided into sub modules. Okay, and each module is made a reusable. And modular programs are usually easy to code, debug, and we can also easily alter. Andre ಈಗ suppose you can take an example, each devices. Okay, each controlling we are writing the programs. Okay, that is a splitted program. Okay, ನಾವು ಎಲ್ಲಾ ಪ್ರೋಗ್ರಾಮ್ ಒಂದೇ ಕಡೆ ಹಾಕ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹಂಗಾಗಿ ನಾವು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಬಿಟ್ರೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫಂಕ್ಷನ್ಸ್ಗೆ ನಾವು ಕಾಲ್ ಮಾಡಿದ್ರೆ ಆ ಸಬ್ ಪ್ರೋಗ್ರಾಮ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಓಕೆ, ಎನಿ ಮಾಡಿಫಿಕೇಶನ್. ಓಕೆ, ಈಗ ಸಪೋಸ್ ಟೈಮ್ ಡಿಲೇ ನಾನು 10 ಸೆಕೆಂಡ್ ಆದ್ಮೇಲೆ ಅದು ಸ್ಟಾರ್ಟ್ ಆಗ್ಬೇಕು ಅಂತ ಇರುತ್ತೆ. ಓಕೆ, ನೀವು ಹೋಗಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು ಸಬ್ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ ಇದ್ದಿದ್ರೆ, ಸಬ್ ಮಾಡ್ಯೂಲ್ಸ್ ಆಗಿ ಇದ್ದಿದ್ರೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ಅಲ್ಲಿ ಹೋಗಿ ಈಸಿಯಾಗಿ ನಾವು ಟೈಮ್ ನ ಚೇಂಜ್ ಮಾಡ್ಬೋದು. 15 ಸೆಕೆಂಡ್ 20 ಸೆಕೆಂಡ್ ಮಾಡ್ಬೋದು. ಅದಾಗ್ತದೆ. ದಟ್ಸ್ ಒನ್ ಆಫ್ ದ ಈಸಿ ವೇ ಟು ಮಾಡಿಫೈಂಗ್ ದ these sub modules. Okay, again it is very easy to code. Okay, we can recode that one, reusable also. Again we can alter, modify it also. We can also debug also be very easy in the modular program. See, you can see the diagram. Okay, this is the block diagram for the assembly language to machine language conversion process. Okay, see, initially I told you there's a source. Okay, all the assembly language program is stored in the .asm or .src files. Okay, this is a module one. Okay, this is a model assembly. This is a object file one. Okay, this is a library files. Okay, you can see how the process will be going on. Okay. See, that is the source file, object file, translations. Okay, the first one is what is that source file is there now. The assembly language will be stored in the .asm. There is a source file one. Okay, like the source file one will be there now. The source file to object file translation. Here in this transition, translation of assembly code to machine code is performed by the assembler. ಅರ್ಥಾತ್ ಏನ್ ನೀವು ಅಸೆಂಬ್ಲಿ ಕೋಡ್ ಇರ್ತಲ್ಲ ಅದು ಮಿಷಿನ್ ಕೋಡ್ ಆಗಿ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಅಸೆಂಬ್ಲರ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ದ ಸೋರ್ಸ್ ಫೈಲ್ ನ ನಾವು ಎಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಮಾಡ್ಯುಲರ್ ಅಸೆಂಬ್ಲರ್ಗೆ ನಾವು ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಮಾಡ್ತಾ ಇದೀವಿ. Okay, the assembler for different target machines are different. A51 microassembler from Kill Software is a popular assembler for the 8051 families microcontroller. Okay, ನಾವು ಏನ್ ಮಾಡಿದ್ದೆವು in the previous year ಅಲ್ಲಿ ನೀವು microcontroller ಯಾವ ಸಾಫ್ಟ್ವೇರ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ Kill ಸಾಫ್ಟ್ವೇರ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ನೀವೇನ್ ಬರ್ತಿರ್ತಾರ ಸೋರ್ಸ್ ಫೈಲ್ ನ ಅದು ಅಸೆಂಬ್ಲರ್ ಮೀನ್ಸ್ ಮೆಷಿನ್ ಕೋಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವು Kill ಸಾಫ್ಟ್ವೇರ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, the various steps involved in the conversion of the program written in the assembly language to corresponding binary file or machine language are illustrated in that particular figure. Again, the each source module. Okay, the each source module written in assembly and it is stored in the .src files or .asm files. Each files can be assembled separately to examine the syntax error and incorrect assembly instructions. Okay, after writing what you should examine that particular file assembly language. Okay, if any syntax error or incorrect instructions ಇದೆಯೋ ಅಂತ ನಾವು ಚೆಕ್ ಮಾಡ್ತೀವಿ. Okay, that's why on successful assembling, after assembling ಆದ್ಮೇಲೆ each source files corresponding object file is created to extension dot objective. Okay, dot objective ಎಲ್ಲ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ assembly ಅಂತ ಅದು objective ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ. Okay, see the microcontroller there is a set of procedure will be there after writing assembly language, then you will go for the source file, after assembly file, after assembly then you go for the object files. The object file does not contain the absolute address of the where the generated codes needed to be placed on the program memory, and it is called as relocated segments. It can be placed at any code memory location, and it is the responsibility of the linker, okay, or locator to assign the absolute address for the modules. And in each modules can share the variables and subroutine among them. Keyword, they can use the keyword as a public or enter n. Okay, extra n can be used for addressing the shared variable and subroutines. And then next to the library files. Okay, the next to the library files, creation and usages. Library are specifically formatted ordered program collection of the subject modules that can be used by the linker at the later timer. Okay, library file will be generated with the extension of dot library. Okay, library file ಯಾವ ತರ ನಾವು create ಆಗುತ್ತೆ extension ಆಗುತ್ತೆ ಅಂದ್ರೆ dot library. When the linker process a library, only those object modules in the library that are necessary to create the program are used. And library file is some kind of source code hiding techniques. Suppose you can use the library of 51 from the Kill software is an example for the library creator, and it can use to create the library files of A51. This is assembly or C51 are compare. Okay, sorry for the delay, some network issues. Okay, today we'll stop here. Okay, in the library. Okay, next class we are discussing about the library file creation and recycle. Okay, means how it is formatted, how it is linked with the objective models. Okay, example I have given here, library 51. Okay, using from Kill software is an example for the library, and it is used for creating library file for A51 assembler and C51 compiler for the 8051 microcontrollers. Okay, today we'll stop here. Okay, today we'll stop here. The next class again we go for the linker and locators and object to Excel file converters. Okay, another two important topics here. That should become the thing that is being discussed. Today we'll stop here. If you have any doubt regarding today's session, you can ask me any questions. If no doubt, you can leave the session. Okay, thank you, thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, thank you.